Think about every product around you for a second. Whether it's a lightweight automotive component, a super robust aircraft structure, some complex industrial machine, or even just the everyday consumer products sitting on your desk. They all start as a single idea in an engineer's mind. But today, the way we turn those ideas into optimized, real-world designs is fundamentally changing. Welcome to this explainer lesson. Today, we're going to dive into how artificial intelligence is stepping up as a powerful co-designer to help us build things faster, safer, and honestly just better. So how exactly is AI bridging that gap between a raw concept and a fully optimized production-ready design? Well, the whole landscape of mechanical engineering is shifting. We're moving away from tools that just digitally record our manual lines and shapes, and we're moving toward intelligent systems that actively collaborate with us. It's like a giant puzzle, and AI is suddenly handing us the right pieces.
Here is our roadmap for today's explainer. We'll kick things off with an introduction to AI design, move into AI in concept and CAD, check out generative design in action, talk about verifying those designs, look at some real industry examples and mistakes, and then wrap it all up with a summary and knowledge check.
All right, let's jump right into Section 1, Introduction to AI Design. By the end of our time together, you're going to have a solid grip on 4 key things. We'll cover exactly how AI assists design engineers in their day-to-day, how it actively supports early-stage concept generation, how it improves CAD and design optimization, and, this is a big one, how we as human engineers absolutely must validate these AI-generated designs to make sure they're safe and functional. To really appreciate what AI brings to the table, we kind of have to look back at the traditional mechanical design process. You know the drill. We start with customer requirements, brainstorm concepts, spend hours upon hours in CAD modeling, run engineering calculations and simulations, build physical prototypes, test them, and finally hit production. The catch? It is highly iterative and just incredibly time-consuming. We're constantly looping back to manually balance cost, weight, strength, and manufacturability. And if a prototype fails, you're often sent all the way back to step 2. Which brings us to Section 2, AI in Concept and CAD. Imagine you're tasked with creating a lightweight support bracket. Doing this the traditional, manual way, you're basically exploring one single design concept at a time. It's slow. Manually balancing the cost, the weight, the load capacity, and the manufacturing process is frankly exhausting. But drop into an AI-assisted workflow, it's a totally different ballgame. You can instantly generate multiple concepts, explore alternatives in a flash, and lock in optimal improvements super early in the process. You're suddenly looking at a whole menu of highly optimized options. This shift brings us to a really fascinating concept called cognitive engineering. We have officially moved on from standard, static, computer-aided design. Cognitive engineering means your CAD software acts as a true collaborator. It learns from historical design data, predicts the outcomes of physical forces, and proactively suggests better alternatives. It's not just a digital drafting board anymore, it's practically a digital partner.
So, what does this actually look like when you're developing a product? Well, AI-assisted CAD workflows speed up modeling significantly. They take over those tedious, repetitive tasks like standard feature creation and basic drawing layouts. The software offers intelligent design suggestions and can even run automated rule checking against standards like ASME codes to flag compliance issues before they become a headache. But, and this is crucial, AI accelerates the process. It absolutely does not replace your foundational engineering knowledge. You still have to know exactly what you're doing.
Let's keep moving. Section 3. Generative design in action. Generative design is where AI really flexes its muscles as a co-designer. Here's how the magic happens. You, the engineer, feed it the critical requirements. You define the material, the manufacturing method, whether that's CNC machining or 3D printing, the required load capacity, and your strict limits on cost and weight. The AI system takes all those constraints, runs with them, and explores thousands of possible geometric solutions. It then brings back an array of optimized configurations for you to pick the best one. This brilliantly illustrates exactly what generative design can produce. AI algorithms can generate these incredibly complex, almost organic-looking wireframe structures that perfectly balance minimum weight with maximum strength. These designs are an absolute game-changer for aerospace or automotive components. I mean, shaving off just a few ounces without sacrificing any structural integrity, that's literally critical to performance and fuel efficiency. And the business impact? It's staggering. By leveraging these AI systems, engineering firms are seeing up to a 40 to 60% reduction in design cycle times. They're getting to market twice as fast, creating products that are lighter, using less material, and ultimately lowering their overall carbon footprint. That is massive. All right, let's look at Section 4, Verifying AI-Generated Designs. Because let's be real for a second. As amazing as AI is, it's not infallible. While AI can automate rule checking against vital standards like ASME Y145 for dimensioning and tolerancing, the human engineer must still take final responsibility. You have to verify the specific loads, confirm your boundary conditions, double-check the material properties, and ensure the safety factors are actually appropriate for the real world. Luckily, AI helps us out with the verification process too. It drastically speeds up design checks by learning from past finite element analysis, or FEA, and computational fluid dynamics, CFD, data. It can estimate stress distributions and fluid flow behavior almost instantly. You don't have to run computationally heavy simulations from scratch every single time. It helps prep boundary conditions and is fantastic at spotting possible structural weaknesses super early in the virtual environment. This all comes down to professional responsibility. Mechanical engineers face immense pressure from crazy short production timelines, which can force rushed decisions and, unfortunately, impact safety. Now, AI is an amazing tool to relieve that pressure by speeding up your workflow. But as the ultimate decision maker, you can never rely on it blindly. The safety, compliance, and public well-being behind a product remain your absolute responsibility, not the software's. Let's tie this together in Section 5. Industry examples and mistakes. Let's put this into perspective with an automotive bracket. In a traditional workflow, concept generation is entirely manual, so you only get a few designs. Performance evaluation requires time-consuming math, and validation leans heavily on late-stage prototypes. But with AI, the system spits out thousands of lightweight concepts instantly. Performance and weight comparisons happen on the fly. You basically become the curator, selecting the optimal design, running early virtual tests, and using the physical prototype just to confirm your expected results, rather than crossing your fingers and hoping you don't discover a massive flaw. But beware, with shiny new tools come new pitfalls. You absolutely must avoid these common mistakes. Never accept an AI design without running your own rigorous analysis. Don't ignore real-world manufacturing limitations. Just because the AI can draw a crazy shape doesn't mean a CNC machine can actually cut it efficiently. Always verify your material selection. Never skip physical prototyping. And be super skeptical if your AI is training on incomplete or inconsistent data. Garbage in, garbage out absolutely still applies in the age of AI. Finally, let's wrap this up with Section 6, Summary and Knowledge Check. Okay, here are the core takeaways I want you to remember from this explainer. AI is unparalleled at helping us explore vast design options and completely crushing those mind-numbing repetitive workflows. Generative design is a powerhouse, but it entirely depends on you feeding it specific, accurate constraints. Yes, AI accelerates simulation and rule checking, but above all else, analytical thinking is the single most critical skill for engineers today. Your human engineering judgment remains absolutely 100% essential. Let's do a quick knowledge check to see what's stuck. Ask yourself, can you confidently explain that AI's role is to act as a co-designer? Can you define generative workflows as exploring solutions based on constraints? Can you articulate why human verification is non-negotiable for safety and manufacturability? If you also know the three main design factors, cost, weight, and strength, and that AI slashes design time by automating repetitive tasks, then you have firmly grasped the core concepts of this lesson. So I'll leave you with this as we look toward the future of our industry. The choice is ultimately yours. Will you be the engineer who just lets AI do the basic work, leaning back and hoping for the best? Or are you going to master this technology, apply your hard-earned analytical skills, and collaborate with AI to safely and creatively push the absolute boundaries of what's mechanically possible? Thanks so much for joining me on this explainer, and keep innovating.